So we're looking at page 26, the addition rule questions. First question, well, for all of them, we have to decide if it's mutually exclusive or not. Right? So whether or not there's an overlap between having a card that is a 7 or a king, because that'll dictate the approach that we use. So I'm looking at this and I'm saying, all right, here's my set of 7s. You can make that a little bigger. Here's my set of 7s. Here's my set of kings. There's no way you could have a card that is a 7 or a king concurrently. So this is an instance where we can just simply add the two probabilities. All right, so this is mutually exclusive. So all I need to do is take the probability of 7 and add to it the probability of getting a king, or quality king. All right, clean that up. All right, there's 4 cards in the deck that are 7s out of 52 available. There's 4 cards in the deck out of 52 available that are kings, for a total of 8 out of 52. If you have the sample set available, sample space, all you'd have to do is say, well, I got 4 of those and 4 of those, for a total of 8 of those. All right, so that's easy enough. But then you get to something like 7 or prime. All right, so it's a little on the trickier side. All right, so here I'm looking at cards that are 7, cards that are prime. All right, the prime numbers, if you refer to a previous page or look it up, 2, 3, 5, that's not a 5. It's a function of me not being able to see. 2, 3, 5, and 7 out of the deck. I mean, there's many more prime numbers in existence, but out of the deck, the only ones that are relevant are those values. All right, there is some overlap. So there's 2 ways to handle this. One is just look. If you have the sample space available to you, you already know. First off, this is not mutually exclusive because you could have cards that are both 7 and prime at the same time. Those are the 7s. So not mutually exclusive. So I would say simply 16 out of 52. But if I want to use the general addition rule, I would say the probability of getting a 7 plus the probability of getting a prime number minus getting a card that's both a 7 and a prime number. All right. The notation for the and, again, is that almost letter A. All right, so, it doesn't have the crosshatch there. So that's the notation, just in case you come across that. All right, just thinking about it, without restriction, there are 4 cards in the deck that are 7s. So 4 out of 52. All right, there are 2, 3, 5, 7. That's set times 4 for each of the suits. So total of 16 cards. If a question just said, what's the probability of getting a prime in the deck without any other considerations, we would be saying 16 out of 52. But then I would be looking for the probability of getting a card that is both a 7 and prime at the same time. So that's 4 out of 52. All right. So these 2 fractions would cancel because they're opposites, and you'd be left with 16 out of 52. All right. So some people get very concerned by this and say, well, do we have to do it this way? You have to do it in a way that gets you the correct probability. Right? In some cases, it means that you're going to show more work, and in other cases, it means you're going to do it in your head. It does not matter to me. All right. For part C, prime or even. All right, so we have our primes. Now I want to look at evens and see if there's any overlap. All right, so I'm just going to kind of clean this up and get this purple out of here now. So I got all my primes, and now I'm going to look for evens. So this is an even. So is this, or this. We ignore anything that doesn't have a number on it. So anything that has some kind of shading, whether it's double shaded or individually shaded, is going to be counted. So I'd have 4, 8, 12, 16, 20, 24, 28, 32 out of 42, out of 52. All right. So I could come up with that answer straight away. But I could also look at the fact that it's not mutually exclusive, which means that there's some overlap. I'd be looking for the probability of getting a prime number plus the probability of getting an even number minus the probability of getting a number that is prime and even. All right, so we already know that there's 16 primes in the deck. Evens. 2, 4, 6, 8, 10 times 4. 2, 4, 6, 8, 10 times 4. No. Let me rephrase that using a method that I like to call the right way. There are 5 cards. 2, 4, 6, 8, 10. If I count off my fingers, those are the numbers, but there are 5 of those numbers. Times 4 is 20. All right, and then we just look for the instance where we have a double shading. All right. Now I kind of did my shading quickly, but not so quickly that you can't see. Hopefully that, this one's got some pink and some green. That's the double shaded. That happened for 4 cards, the 2s. And that makes sense. 2's prime, but it's also even. So 4 out of 52. So I'd be looking at, all right, I got 36 minus 4 is 32 out of 52, which is what we got just by counting. So again, if you have a sample space in front of you, you use it. You get your answer really quickly. If you don't, then you got to do something else. All right, 7 or not red. Well, in a deck of cards, it's a binary situation. The cards are either red or they're black. But if you're playing a game like roulette, you could have red, black, or green. So in this case, if I'm saying that a card is not red, then based on the rules of the game, I'm saying that it's black. So I'm looking at the probability of getting a card that is 7 or black. All right, there is overlap because you could have cards that are black and 7s at the same time. So I'd say so there's mutually exclusive, not mutually exclusive, apologies. Because there is some overlap. 7 plus the probability of getting a black minus the probability of getting 7 and black. All right, so we know that there's 4 7s in the deck. We know that there's 26 cards in the deck that are black because half the deck is black, half the deck is red, and half of 52 is 26. Now the 2 cards that are black and also 7 is the 7 of clubs. Yeah, look at that club. And 7 of oh geez, I don't even know why I bother. And there we go. Kinda. There are 2 cards. I should have just wrote the words out. 2 out of 52. Alright. So you get the 28 out of 52. But if you really reason it out, it becomes kind of a mental logic game. Where you say, if a card is not red, it's black, but the same relationship exists between the 7 card and the black cards versus the 7 card and the red cards. So whatever you get due to symmetry for the 7 or red situation would have to be the same as the 7 or black situation. But that's kind of a deeper level of thinking that, it really only starts to take place once you start really kind of diving into this stuff.